Expanding and condensing logarithms. So here are some properties of logarithmic functions. If b, capital M and capital N are positive numbers and b is not equal to 1, then these three things are true. So let's look at each one. Well, this one says log base b of some product, m times n, is equal to log base b of m plus log base b of n. We know that log base b of m is equal to some p, and that can be rewritten as an exponential, right? B to the p equal n. Remember that the base of the exponential and the logarithm are always the same. And then we switch the inputs and outputs, right? If this logarithm operates on m, it's an input here. It has to be an output here. That should be an n, right? And then if this logarithm has an output of p, that means the input of the exponential is p. We're just switching inputs and outputs, right? B to the p equal m. So that means every time you have a logarithm, the output was really a power of an exponential, right? This represents a power of some exponential. So does this. So does this. Okay, and what do you do if you have powers, common bases multiplied together, like b to the fourth times b to the fifth? Well, the base is the same, so then you add the powers, right? So does it seem reasonable that you're adding powers here? Hopefully. Let's look at an example. So if we have something like log base, 5 of 125. Well, using this property up here, b to some power equals m. So let's just call this x for now, right? So we can say, well, 5 to the x is equal to 125. Because we're undoing this logarithm, writing it as an exponential. 5 to the x is 125. Well, that means x is 3. Okay, so we see that log base 5 of 125 equals 3. So if instead of writing log base 5 of 125, what if we wrote it a little bit differently? What if we wrote log base 5 of maybe 5 times 25? Well, using this property, that's log base 5 of the first piece in the product here, so log base 5 of 5, plus log base 5 of the back piece in the product, right? Well, log base 5 of 5 is equal to like y, right? So the undo that, you say like 5 to the y equal 5. Well, that means y is 1. So that means this right here is 1 plus. And do this the same way. So maybe this is equal to like z. So then 5 to the z equals 25. So then z is 2. So that's 2. 1 plus 2 is 3. And didn't we say that log base 5 of 125 is 3? So do you see it's the same thing? But it comes from this property that if I have a logarithm, this is a power, right? And these are also powers. When I multiply things together, common bases, I add the powers. Look at the next one. Log base b of m divided by n is log base b of m minus log base b of n. I won't do a full example, but I do want to remind you that if you have something like b to the 7 over b to the 3, we can rewrite that as b to the 7 minus 3, right? You subtract the powers. So again, log base b of m over n, that's some power. And these are also powers. Does it seem reasonable we're subtracting? We can combine powers? Hopefully it does. Okay. And then we have log base b of m to the p equals p times log base b of m. What we've done here, this one's really cool, is if our operand has a power, we can move it to the front and it can be the coefficient of our logarithm. So that's kind of neat. So if we have b to the 8th to the 4th, that's a power raised to a power. We multiply the powers. Well, here's the power that you multiply. That p was a power, right? And you're multiplying by this other power. So again, hopefully these seem reasonable. We just sort of talk about this. If you want a formal proof, you can probably Google it. Okay, let's do an example. And I've written the properties to the side. When you're doing your homework, you should write down the property every time you use it. By the time you've done your assignment, you'll know all the properties. So this is log base 8 of 3x to the 5th. Notice, it may not be obvious, but there is a product in here. So this is log base 8 of 3 times x to the 5th. So you see we have a log and there's two things multiplied together. We have this product right here. So I'm going to highlight. We're going to use this property first. So this is log base 8 of 3 plus log base 8 of x to the 5th. And that's this property right here. Okay, we're almost done, but we want all of our operands to have powers of 1. So we see that our operand has a power, so we're going to use this property right here. We are going to take that power and we're going to move it to the front to be the coefficient of that logarithm. So this is going to be log base 8 of 3 plus 5 times log base 8 of x. So we use that property right there. Okay, isn't that fun? Let's do another one. This one's a little more interesting. There are more pieces in our product. We have log base 7 of 2 times x to the 8th times y to the 6th. So let's make sure we can visualize that is actually a product. That's 2 times x to the 8th times y to the 6th. Now our property only shows two things multiplied together, but if we have more than two things, we're still going to keep adding our logs. Okay, so we're going to write this as log base 7 of 2 plus log base 7 of x to the 8th plus log base 7 of y to the 6th. That's this top property right here. Oh, but look, some of our operands have powers. So we can use this property down here to move the powers. We can move this 8 in the front to be the coefficient of that logarithm, and also the same with the 6, right? So this is log base 7 of 2 plus 8 times log base 7 of x plus 6 times log base 7 of y. Isn't that fun? Let's try another one. And if you notice, on the next one, looking at number 3, looks pretty similar to number 2, except now it has a denominator, right? So all the work we did here, all of this expansion is going to be true for the top. Let's do one step first. Let's look at this as this whole thing is going to be my numerator and this whole thing is my denominator. So now I'm going to use the middle property. Okay, so we're going to have log base 7 of 2x to the 8th, y to the 6th, minus log base 7 of z. So do you see that's the middle property? Again, every time you're doing these on your homework, write down the properties. That way you'll know them by the time you're done. Well, the previous example was this first part, right? So we know this first piece expands to those three logarithms added together. Log base 7 of 2 plus 8 log base 7 of x, plus 6 log base 7 of y minus log base 7 of z. So what I'm saying here is this stuff right here was that piece right here. Okay. Let's make the bottom even more interesting. So we're going to still look at this as a numerator and a denominator. Log base 7 of a fraction. Well, that's going to be log base 7 of 2x to the 8th, y to the 6th, minus log base 7 of 5t to the 9th times z. Well, we already did this piece, right? That was this up here. But log 7 of 2 plus log base 7 of x to the 8th plus log base 7 of y to the 6th, right? And then we move the powers to the front. Okay, so we end up with log base 7 of 2 plus 8 times log base 7 of x plus 6 times log base 7 of y. Again, that's the first piece. But now we're having this other piece. Here we're going to do the same thing, but we're going to have a minus sign in front. So log base 7 of 5 plus log base 7 of t to the 9th plus log base 7 of z. We're going to distribute that minus sign. So this will be minus log base 7 of 5 minus log base 7 of t to the 9th. This 9 can come to the front, right? Can't I use that property I had before? And this is minus log base 7 of z. So there we go there. Now there's something very interesting about this. If you look, log base 7 of 2 plus 8 log base 7 of x plus 6 log base 7 of y, all of that came from the numerator. I want you to look at the signs, plus, plus, plus. All the coefficients have a positive in front. And then look at the ones that came from the denominator. 5, t to the 9th, right, because we can move that power, and z. Coefficients are negative. So anything that comes from a numerator is going to have a plus. Each of these is going to get its own logarithm. So we're going to have log base 11 of 4, because that's the first piece. There's a 4. Then we have an a squared and a b cubed. So plus log base 11 a squared. But I could really put that 2 down here, right? So 2 log base 11 of a plus log base 11 of b cubed. But again, I could put that 3 in front instead. Those came from the numerator, so all the coefficients are pluses. Now we do the same thing with the bottom, but these all get minuses. So check. Plus, plus, plus. So 4a squared, b cubed. Then we have a 2 on the bottom, coefficients minus. Have a c to the 6th on the bottom. So remember, the 6 could go back and forth. It could be the power of the c or the coefficient. And then d to the 5th, d to the 5th. We can use this idea, and we can now take an expanded logarithm and put it back together. So remember, if the coefficient of a logarithm is positive, that term is going to go in the numerator of the new logarithm. The coefficient is minus, it goes in the denominator. So numerator, numerator. This one's going to be in the denominator. Is the base the same? Log base 10, log base 10, log base 10. So we write this as one big log. Draw your parentheses, draw your vinculum. Your vinculum is your fraction bar. And then the 13 had a positive coefficient, so it goes on top. Now we did these properties. We're going to do them in the reverse order as well. So let's start with the other one that's positive. Plus 3 log y. So the first thing we're going to do is move the power back to the operand. So this is like 3 log y is the same as log y cubed. So this is like log 13. We're going to do the same thing here. Minus log x squared plus log y cubed. So again, this one goes to the numerator. This one's in the denominator. This one's in the numerator. So 13y cubed. Denominator is x squared. So the first property we're really using is log base b of m to the p equals p log base b m. But we did it in this direction, right? So let's actually write it that way. P log base b of m equals log base b of m to the p. We used that one. And we also use the property that log base b of m minus log base b of n equals log base b of m over n. We also use the property that log base b of m plus log base b of n equals log base b of m times n. Let's do one more. So write as a single logarithm. First thing we're going to do is we're going to look for coefficients. Are there any coefficients that we can use this property of? We can move a coefficient back to be the power of the operand. Well, yeah, there, and there, and there. And then we're going to look at anything that has a coefficient that is positive. When I rewrite it, will go in the numerator. So again, we use p log base p of m equals log base b of m to the p. We move this power back to be, instead of a coefficient, the power of the operand. Now we check our signs. Positive, so that goes in the numerator. Positive, that one goes in the numerator. Those are the only ones. Then we see we have a negative, so that one goes in the denominator. A negative, that one goes in the denominator. And a negative, that one goes in the denominator. All of the bases are 9, 9, 9, 9, 9, 9. So this equals log base 9. A big fraction bar. We're drawing our vinculum. The things that go in the numerator are the operands of these logarithms with positive coefficients. So we have 5x cubed. Okay, and then the negatives, any coefficient that's negative, its operand goes in the new denominator of this logarithm. 2 and a y to the 4th and a w cubed.